Hi class, here we go with section 4-3. We are going to start to look at congruent polygons and more specifically congruent triangles in this lesson, and this will take us through most of the rest of the chapter. So let's go ahead and dive right in. The first thing you need to know is what just kind of congruent, remember, means equal length or equal measures, but when we're referring to polygons, congruent polygons might be positioned differently, but they're going to be the same shape and the same size. And things that are not congruent, these here are all the same, or these two are the same shape, but they're different sizes. That'll be something we look at later. That's called similar. And these are more roughly the same size, but different shapes. So our actual kind of definition of what congruent polygons are, I'm just going to write down that all of the corresponding parts, which are like the matching parts, are going to be congruent. Here is how some of the questions are going to look. They're going to have a picture of a couple different congruent polygons. In this case, they are congruent triangles. And they'll ask you to list all of the corresponding sides, the corresponding angles, and then write a congruency statement after you have those. This does take a little bit of time, but it should go really fast. The corresponding sides are the sides that kind of match up. So in this case, AB and HJ are corresponding. So I can say that AB is congruent to HJ. Another pair of sides that correspond, BC and JK. So I'll write that BC is congruent to JK. And then lastly here, the other pair of sides, I could say that AC is congruent to segment HK. So just writing those out, because these are triangles, they will have 3 pairs of corresponding sides. If they were, quadrilaterals, you would have to write out 4 pairs. Looking at the angles are even easier because they are marked. And if you're ever not sure like how these are supposed to be, look at the markings in the picture if you're not sure exactly what the corresponding or the matching sides and angles are. So the corresponding angles, I can say that angle A is congruent to angle H. I can say that angle B is congruent to angle J. And then lastly, angle C is congruent to angle K. And there's no particular order for those, it's just whatever you look at first. The congruency statement will be saying that these polygons, in this case these triangles, are congruent to each other. And this is a little bit more picky with how you write it out, because you have to match up the corresponding parts. So if you have the corresponding angles, it's easy enough to just put each pair in the same corresponding placement. And different people may have different answers for this, and that's okay, as long as the corresponding parts are in the same order. So if I'm going to say a triangle, let's say ABC, and I could have said that triangle in any order, it just kind of makes sense to do it alphabetically. I have to make sure that whatever letter I put first is the corresponding one with angle A. So looking at this, the corresponding one with A is H. So I'm going to say it's triangle H, and then J, and then K. Because you don't actually need to even have a picture. If you have a congruency statement, you can tell what the congruent angles are because they'll be in the same place. You can also tell what the congruent segments are. For example, segment AB is congruent to segment HJ. Or even segment BC is congruent to segment JK. All of this information is contained within that congruency statement. So it's really important that you get those in the right order, otherwise it won't be correct. And we'll practice that. Looking at these two, it's a little harder to tell which ones are corresponding, but again, if you look at the different side lengths that are marked or look at the different angle measures, that might help you figure it out. So looking at the corresponding sides, I could say that LJ is congruent to, let's see, that's going to be QP. We have LK congruent to QM. And again, I'm just matching these up. That's the 40, that's the 40. I'm not going to be too picky if you would have said LK and then MQ and had it the other way. I'm not going to be too picky about that one. And then let's see, lastly, what other one do we have to do? We have JK. So segment JK is congruent to segment PM. Again, the angles are a little quicker. Just match up the angles that are corresponding, and you can just look at the different angles or the different congruency marks depending on how the picture is set up. So I can say that angle L is congruent to angle Q. We have angle J congruent to angle P. And lastly, angle K is congruent to angle M. And then most importantly, our congruency statement saying what triangles are congruent. If I had this, I would just do it in the exact same order. So I would say triangle LJK is congruent to triangle QPM. And then that would guarantee that I have it set up right, where, you know, like the second one corresponds with the second one, the third one corresponds with the third one, etc. This CPCTC that we see here, this stands for something that we're going to use quite often, and it's just a way to abbreviate it because it will be so common, and it's kind of fun to say, CPCTC, CPCTC. What it stands for is it stands for corresponding parts of congruent triangles are congruent. And it just takes the first letter of each of those main words. So C, P, C, T, C, and lets you know that if you know triangles are congruent, then you know all of their corresponding parts are congruent. Like what we just did in the last example where we listed out all the pairs of corresponding angles that are congruent and all the pairs of corresponding sides that are congruent. And this is just a way of like kind of abbreviating that. Once you know triangles are congruent, you know that everything's congruent. And if everything's congruent, then you know the triangles are congruent. So in this example here, this kind of algebra-based example, it tells me that in this picture, in this diagram, triangle RSV is congruent to triangle TVS, and they want me to solve for x and y. Sometimes this is easier to see than other times, and if it's ever kind of hard to see, like I feel like it might be kind of hard to see in this picture, again, remember you can always look and see where the corresponding parts are. So you might be looking at like this side here and you think, okay, is this side the same length as the 24 or the 24.5? Because those are really close, but it won't be the same as both of those. What you can do is you can look to this congruency statement, this statement RS, and see which part matches up. So TV is in that same spot, so that's going to let you know that those two parts are the congruent parts. So to solve for y, I can set 2y minus 1 equal to 24, and then I can go ahead and solve that. So 2y equals 25, or y is going to be 12.5. If I'm solving this for x, x is right here. It's this angle T. Angle T is this first one, and that's corresponding with angle R. Looking here at angle R, you might notice that I don't have how many degrees that angle is, but that doesn't mean that I can't find it out, because looking at this triangle, I have 2 out of the 3 angles within there. So I can find this angle. I can add the 90 plus the 78 and take that away from 180, Or if you remember, since this is a right triangle, these two are going to add up to be 90. So I would probably just think in my head, okay, what is 90 minus 78? So this angle is going to be 12 degrees, and it's just that's what x is. So x is going to equal 12. The next thing in the last theorem in this section is called the third angles theorem. And we actually just used the third angles theorem kind of indirectly with just this one triangle. The third angles theorem says that if you have two angles, so if two angles in one triangle are congruent to two angles in another triangle, then the third angles are congruent. And I'll just kind of sketch this out really quick with a couple of right triangles just to make it easier to just kind of sketch out. If I know that these two angles are congruent, and let's say I know that both of these angles are both 75, and you wouldn't even have to know their exact angle measures, you would just have to know that they're congruent to each other. What that would mean is that would automatically mean that these two angles are congruent, because every triangle is going to add up to be 180, and if these two add up to be the same as those two, that means that the third angles are congruent to each other. And you'll see how this works when I do the next couple of proofs. But the reason for that, like the reason in the proof, that would be the third angles theorem. Lastly, let's do a couple examples of these. Now let's see a couple examples of these. When you want to prove that triangles are congruent, it's a little tedious right now, but you're going to have to say that all of the sides and all of the angles are congruent, and probably most of that they'll list out as given information. There's a couple of different ways that you can do your proofs. I'm going to show you the first one as a two-column. So we have on the one side our statements, and we have on the other side our reasons. And some of this stuff is a personal preference. If you would like to have 7 steps, you can. 6 steps are going to be saying all the sides and all the angles are congruent, and then your last step will be saying the triangles are congruent. If you notice here, I have 1 pair of angles and then 3 pairs of sides all given to me. If you want to list all of that stuff out in step number 1 and just say the reason is simply given, that would be fine too. I think that's what I'm going to do, because I think I'll run out of room if I try to list them out separately. But that's a personal preference. I've seen kids, they like to have them on different lines. That's just kind of whatever floats your boat, I guess. So we have those congruent, we have LN congruent to PN, and lastly we have MN congruent to OP. So again, like I said, that's 4 of the 6 things that we need. I need to come up with a reason why both other pairs of angles are congruent, and they don't give me any extra information like they're going to give me in other things, so I just have the picture to go off of. Looking at this, do you see that these 2 angles here in the middle are vertical angles? Well, because those are vertical angles, you can say that they're congruent. And you have a couple options as to how you can do this also. I'll explain the first one, and then I'll say what I would do if I were you. So the first one would be that you could say that LNM is congruent to angle ONP, and you do have to use the 3 letters for those, because if you just say angle N, we don't really know what angle you're talking about. So here's what I would do. I would say that I'm going to put a little 1 and a little 2 in here. And if you're going to use this, you have to mark it on your picture so that the reader of the proof, which will probably be me, knows where you're talking about. But looking at this, I can then say that just angle 1 is congruent to angle 2. And because I've marked that on there, I can do that. And that just, it makes it a little easier to see, and then it's just a little less to write. Because again, remember, if you're going name them the other way, you have to use the 3 letters. And the reason for this is the vertical angles theorem. So all of this stuff from before is going to come back around. And then now I have 2 out of the 3 angles for each of these triangles. I really should have put 2 marks on there. I can now say that angle M is congruent to angle O, and then this is an example of the third angles theorem. When you have 2 other pairs of angles congruent, then you know the third angles are congruent also. So again, I have 1, 2, 3 pairs of angles, and I have 1, 2, 3 pairs of sides. So now what I can do is I can say that triangle LMN is congruent to triangle PON, and that's going to be the definition of congruent triangles. And there we go. For this next one, I start out with different given information. Here I'm actually only given 3 things. I have 1 pair of angles marked congruent, and I have 2 pairs of sides. I'm going to show this one a different way. I'm going to show this one as a flow proof, and I don't think we've done any flow proofs up until this point. Some people really like this, and other people really like the 2-column. I'll kind of show both, and it'll be a personal preference for you again, which way that you like. I don't know if you remember, but there is another one. It's called the paragraph proof. That is, it seems to be by far the least favorite, but you have to like write out everything. You still have to write out all the reasons, but you do it more in a paragraph form. If that's something that you're interested in, I could help you with it. But probably I've had like 2 students over the last 12 years say that that's their favorite. So my guess is one of these 2 will be like the way that you like to kind of write things out. So for the flow proof, what you do is you put the statements in boxes and you put the reasons underneath. And then you can draw arrows to kind of show the flow of the proof. So I am going to try to write small enough to squeeze all of this stuff in here. And you can go ahead and copy it down to, we have the different sides and the different angles that are congruent. Hopefully you have this paper, and if you want to, just for your notes, just go ahead and write down, draw an arrow or something. That'll be okay with me for your notes. But I'm going to wait, and I'm going to put that L bisects this segment in a different box, even though that's given 2, just to show you one of the benefits of a flow proof. So I'm going to put that L bisects KM as given also. So one nice thing about a flow proof is you can very easily just kind of show what statement makes what conclusion. So if L bisects line KM, looking at that, what does that mean? Well, to bisect means to like cut it in half or cut it into 2 congruent parts. So I can say that KL is congruent to LM, and that's a definition. Definition of, you could write segment bisector, or if you just want to be general and say definition of bisector, that would be fine. So even though this didn't directly say a segment was congruent, it indirectly let me know another pair of sides are congruent, and you should probably be marking that on your picture. And then the end of this proof looks almost identical to the end of this one, because I have these different vertical angles that are congruent. So I can say that, I'll use the letters this time. So JLK is congruent to angle PLM, and that's the vertical angles theorem. And then you have also, I'm kind of running out of room on here, sorry. You have on here that angle K is congruent to angle M. That's the third angles theorem. And now I've had, let's see, I have 1, 2, 3 pairs of angles and 1, 2, 3 pairs of sides. So for a flow proof, ideally you'd have a little more room than what I have right now, but you would kind of like have all of these things coming together to say that these triangles are congruent. So triangle JLK is congruent to triangle PLM, and your reason is the definition of congruent triangles. So yeah, again, sorry I kind of ran out of room on here, but hopefully it makes sense. It looks a whole lot like this one, with the exception of we had to use the definition of a bisector there. Something else that will kind of take place, and I don't remember exactly where you'll see this first, but another reason that's pretty common is maybe definition of midpoint, or that doesn't quite look congruent. One thing that you'll see a lot is you'll see like a side that's shared between 2 triangles. You would say that segment AB is congruent to segment AB, and even though we did this in chapter 2, it probably didn't make a whole lot of sense as to why we did it, but in this chapter you'll see it a ton. This is the reflexive property. When you have one side or one pair of angles that's the exact same for each triangle, you'll see that a lot. And I'm not going to do anything else with this other than just to point it out. I put it on your note-taking guide just so you have it, so you can see that these properties hold true for triangle congruency also. The reflexive property, not only does it work for sides or angles that are congruent to themselves, it works for entire triangles. Triangles are congruent to themselves. You could flip the order around for the symmetric property, and that still holds true. Or even transitive. You have one triangle congruent to a second triangle, and that same second triangle is congruent to a third. Therefore, you can say that first is congruent to the last. I hope this helps, and I look forward to helping you guys a lot in class.